Bro, hurry up. Come on. Oh. What movie you watching?
Mowgli.
You mean the Jungle Book?
Yeah, the Jungle
But
Book.
they've made 3 dozens of those since 1937.
Yeah, but this is the best one. Listen to him. This is the best one.
Go on and put it on.
All right, I'm putting it on.
Nah, the best Jungle Book is the original 1967 classic. Shh, don't tell him, he'll get upset.
Do me a favour. Get me a lemonade, please. Oh, that's what he wants, chilled lemonade. I'll tell you what though, this beard, he's amazing. He's helped me so much with math. You should subscribe to his channel. Oh. Let's put it on. Oh, there it is. No, you need to straighten it out. What about now? Is that straight? Now do it the other way, What? All right, that must be straight now, isn't it? Nah, bro, you nearly got it. Just the other way. I'm not gonna be standing up here, I'm sweating already. Listen, just tilt your head to the side. I'm not sitting there tilting my head for an hour and a half. Dude, you need a 0 gradient. Get a 0 gradient on it. Why are you talking about, what's gradient? Just make it horizontal, bro. You're gonna have to tell me what that is. Now? Well, I need to tell you about this gradient stuff. I'm coming. Like I said, we need a 0 gradient, so this needs to be horizontal like that. Don't worry, I've got you covered. I'll show you how it's done and then we'll get back to the movie.
Now slopes are everywhere. We can go up a slope or we can come down a slope. What you need to remember is in mathematics, when we're increasing from left to right, we have a positive gradient. Pause the video and write that down. Look at him go. Right, get back, Mr. Beard. And let's show them with a bit of animation. So as he's going up, you can see we have a positive gradient from left to right, rise over run. That's plenty of fun. If he comes down from left to right, so you're decreasing from left to right, you have a negative gradient. Write that down. Come on, get back up there, Mr. Beard. As Mr. Beard's going down, the arrow's going down. Question you have? Well, if you got up a negative gradient, haha. Well, even if you got up a negative gradient from right to left, it still is negative. You thought you pulled a fast one, didn't you? Right, that's enough of that. I'm getting dizzy. Let's get back onto the work. So remember, in mathematics, we always measure a gradient from left to right. There are 4 classifications for gradient. Upward sloping lines have a positive gradient. So any straight line that is going from left to right in an upward direction has a positive gradient. Next, we have a downward sloping line. Now, all downward sloping lines have a negative gradient, like this one shown here. Thirdly, what if we had a flat surface, so a flat road without any incline or any decline? That would be a horizontal line. So any horizontal flat line has a gradient of 0. There's only one other classification left. Do you know what it is? It's the vertical line. So lines that, like straight walls, okay, anything that's straight vertically has a gradient that is undefined. It's undefined because nor is it inclining or declining. It's just straight up. So it has a gradient which is undefined. Now you might be thinking, what is a vertical step and what is a horizontal step? So let's get on to fixing the projector so we can watch our movie. So here we go, here's our screen. What we can do is apply a grid on top of our screen so we can measure the gradient. So the gradient or the slope is measured by calculating the rise over the run. And you must remember that when we're looking for gradient, we're going from left to right so that we know if it's positive or it's a negative gradient. Now you can see the yellow box represents my screen. What I'm going to do is I'm going to try to find 2 points on the grid that intersect perfectly so I can measure the rise and run. So I'm going to choose this point here, which exactly intersects between the grid and the yellow line. And then this point here, which again intersects between the grid and the yellow line. Now what I can do is I can measure the rise and the run. So if I join those points using a right triangle, I can see that the line from left to right is going downwards, so it's a negative gradient. Now, for me to measure the rise and the run, I can see that I've got 3 units down, so I'm going 3 units down, that's my rise. And then from left to right, I'm moving 12 units to the right, that's my run. Now remember, to calculate the gradient, I just need to do the rise over the run. So I have a rise of -3, we're going down, and a run of 12. So that means for every 3 vertical steps down, I'm moving 12 horizontal steps right. We can simplify this fraction to -1/4. How many 3's going to 3? 1. How many 3's into 12? 4. That's the simplest form of this fraction. And in fact, I can represent -1/4. Like this here. Can you see this little triangle? I've gone 1 down and 4 across. So even though I chose these 2 points here and here, which gave me 3 down and 12 across, I could have chosen this point here and another point here, which would have been 1 down and 4 across. All you need to remember is if you have a Cartesian grid or you apply a grid like this over your screen, that the points must intersect. So my straight line and the grid must intersect perfectly. That way you'll get a good measure of the gradient. Now we can say that the gradient is equal to every 1 unit down to 4 units right. So our gradient is equal to -1/4. It's a negative gradient because we're going downwards. Now that you understand how to measure gradient, let's fix our screen so we can carry on watching the movie. Now that we've understood gradient, let's straighten this out and let's get back onto this movie. Come on.
I've never seen a man cut before. It's so smooth.
Hey, I'm really starting to enjoy doing these in real life video skits. If you liked it, give me a thumbs up and make sure you subscribe and share it out. It really does help the channel grow. Now, if you want to continue learning about gradient, you can click up here to a playlist. And if you want to see another video, and I promise you'll enjoy it, you can click over here. As always, I'll see you in the next one.